notes like you normally would in a normal class. So, welcome to the first video for this week. Today we're going to look at solving quadratic equations. Last week we put quite a lot of time and effort into factorising them. And we will see, as you saw last year, that factorising them is a key element to solving the equations. So, good place to start here is recalling the null factor law. Null factor law states that if you have A multiplied by B is equal to 0, then A and or B must also be equal to 0. So this pops up when we see equations like this: x plus 2, 2x plus 5 is equal to 0. We can think of this portion here being A, this portion here being B. And if we have one number multiplied by another to have a result of 0, then one of those two terms must be 0. So what we do here is we take each term separately and think of it as, well, I can think of that as x plus 2 equals 0. Therefore, take 2 from both sides, x equals minus 2. I almost wrote minus 1. Minus 2, that's our first equation, or first solution rather. Second solution is 2x plus 5 equals 0. So that's thinking, well, if b is equal to 0, then x must be equal to minus 5 on 2. So our two solutions are x equals minus 2 and minus 5 on 2. And this relates to our graphing of quadratic equations, which we aren't up to yet, but we will do soon, by saying that the quadratic equation crosses the x-axis at both minus 2 and minus 5 on 2. Alright. You might hear solutions to a quadratic equation alternatively called roots, because these are called the roots of the equation, where they cross here. Zeros, for example, where it equals zeros, or simply solutions. So those words are all used interchangeably: roots, zeros, solutions, when you're asked to solve a quadratic equation. Alright, so the general plan: convert to standard form. So sometimes the quadratics are hidden in some other messed up form of algebra. You need to rearrange, simplify, convert it so that it looks like that, equal to 0. Step 2, factorise, then find a solution for each factor as we did above. If part 2 fails, we'll use the quadratic formula, and that's next week. So, for these, first one is we are in standard form already, which is fantastic. So we factorise using whatever method we want. 2, 11, 24, 8, 3, 1, 3, 2, 4. This factorises as x plus 4, 2x plus 3 equals 0. Now, once again, there's no particular marks for this stage. Do it whichever way you like. The important thing is you end up here. From here, two things can happen. X can equal minus 4, or x can equal minus 3 on 2. Now, if you're not comfortable with where that second one came from, and I do encourage you to take a couple of extra steps here, there's nothing wrong with writing, well, 2x plus 3 may equal 0. Take 3 from both sides. 2x equals minus 3. Therefore, x equals minus 3 on 2. So our two solutions are x equals minus 4 and minus 3 on 2. And I've got 3 more examples. If you survive them all, I'll show you a vine. And I've just discovered vines. They're amazing. Alright, here. Not in general form. It's a little messed up. So we're going to unmess it up and put it in general form. Expand out. 4x squared plus 20x equals 6x. Take 4x squared minus 3. Chuck everything on the left-hand side. That means adding 4x squared, adding 3, and taking 6x from both sides. So we're going to add 4x squared, take 6x, and add 3. No particular order I'm doing it in, but I've approximately lined them up with their like terms, so we can see where we're going. 8x squared plus 14x plus 3 is equal to 0. Right, factorise. 8, 14, 24, 2, 12, 4, 2, 3, 1. Giving us 4x plus 1, 2x plus 3 equals 0. Then think null factor law, a and b. X is equal to minus a quarter, or x is equal to minus 3 on 2. Alright, and these type you should be quite comfortable with factorising and solving quickly. Next one, once again, not in general form. It's disguised as a different form. It doesn't even look like a quadratic right now. But if in doubt, try and get everything on one line. So on one line, by that I mean get rid of the fractions. So get rid of the fractions here, I'd multiply every term by x. Every term by x leaves me with 1. 3x take 2x squared. And now it starts looking a lot more like quadratic because we've got the x squared term. So then we have 2x squared on this side, take 3x plus 1 equals 0. Factorise. 2 minus 3, 1. That's tough. Actually, it's not tough, I just made an error. That's meant to be a 2. Minus 1, minus 2. 2, 1, minus 1, minus 1. Giving us x take 1, 2x take 1. And remember, at this stage, you can always expand to make sure you end up back at this stage here. Now factor law, x is either equal to 1 or x is equal to a half. Note I've given the solution a slightly different form here. X is equal to 1, comma a half is fine. Or you can write x equal to minus 4, x equal to minus 3 on 2. Either way works. Now, lastly here, looking at this one, the first thing you might notice is actually it's not a quadratic. And it's not a quadratic because if I multiplied that by that, I'd end up with an x to the power of 3. X to the power of 3 is called a cubic. It's the next one up. But the same logic applies. So here, what we can think of is if we can split it up into like an extended null factor law, where we have a times b times c equals 0, what we can say is that, well, one of a, b, or c must be 0, and therefore there's a potential for 3 solutions. So here, I can break that up into easily identifiable factors by factorising the quadratic term within it. So I'm going to leave 2x plus 3 there and factorise this one. X take 2, x take 3 equals 0. Now, each one of those 3 factors, or 3 bracketed terms, provides us with a solution. This one here, x is equal to minus 3 on 2, or 2, or 3. And yes, if you are wondering what implications that has for the graph, this graph is crossing the axis at minus 2 on 3, 2, and 3. You get a wiggle. Now, can you please do these on OneNote and enjoy this?
What I hear when they're teaching me calculus.
Math, inequalities, what that is basically...
Awesome. Enjoy, and I'll see you tomorrow.